Let's take a look at finding the derivative of a couple of functions involving the secant function, the tangent function, and the cosecant function. Our first example is to find the derivative of x times secant x plus tangent x. So we will be using the product rule where we have the x plus secant x term, and we will also be using the sum rule. So let's go ahead and dy dx, or the derivative of y with respect to x, is going to be the derivative of our first term, so x secant x, plus the derivative of our second term, tangent of x. Now, when we go to find the derivative of x secant x, we're going to have to use the product rule. So that's going to be the derivative of the first factor, or x, times the second factor, secant x, plus the derivative of the second factor, secant x, times the first factor, which is x, then plus the derivative of tangent x. So let's go ahead and find these various derivatives. So the derivative of x via the power rule is equal to 1. So we'll have 1 times secant of x plus the derivative of secant x is secant x tangent x, secant x times tangent x. That's our derivative of secant x times x, and then plus the derivative of tangent x is secant squared of x. Now, it doesn't appear there's a whole lot of simplification that can be done here. I would probably write this something like secant squared of x plus secant of x plus x times secant x times tangent x. While we could factor out a secant x, it's not entirely necessary. So there's our derivative of our function y. Our next example, g of x is equal to secant x over cosecant x. Now this is presented as a ratio or a fraction, and so we will be using the quotient rule. So let's go ahead and get started. So using the quotient rule, g prime of x is going to be the derivative of the numerator, so secant x, derivative of secant x, times cosecant x, minus the derivative of the denominator, cosecant x, times the numerator, that whole quantity over the denominator squared, cosecant squared of x. At this point, let's go ahead and insert what we know about derivatives of secant x and cosecant x and try to make some room here. So put a line there, equals, okay, our derivative of secant x is secant x tangent x. So that's the derivative of secant x. Now we need to multiply that by cosecant of x minus, now we need the derivative of cosecant of x. Derivative of cosecant of x is negative cosecant x cotangent x, and then that needs to be multiplied by secant x. This whole thing divided by cosecant squared of x. So we can notice that we are subtracting a negative in our numerator, so we can turn that into addition. We can also notice that we have a common factor of cosecant in our numerator, so we can factor that out. So cosecant of x times secant x tangent x plus secant x cotangent x all over cosecant squared x. And now in doing that, we can divide out one of the factors of cosecant x from the denominator in the numerator, leaving us with secant x tangent x plus secant x cotangent x all over cosecant x. Now let's investigate if there's any simplifying that can be done in that numerator. For example, if I have secant of x times tangent of x, that means I have 1 over cosine of x times sine over cosine of x. And in that form, there's not a whole lot of simplification that can be done, so we'll leave the secant of x times tangent of x alone. Now let's consider our second term, secant of x times cotangent of x. Secant of x times cotangent of x is 1 over cosine of x times cosine of x over sine of x. And notice that in this case we can do some simplifying. The cosines can divide out, and we get 1 over sine x, and 1 over sine x is equal to cosecant of x. So while we cannot simplify secant x tangent x, secant x cotangent x, we can replace with cosecant of x. Expanding this, we now have secant of x tangent of x over cosecant of x plus cosecant of x over cosecant of x, which is 1. Now we saw that we couldn't simplify secant x tangent x, but what about considering what happens when we have secant x over cosecant of x? Can that be rewritten? So if we had secant x over cosecant x times tangent x, which is simply using properties of fraction multiplication to rewrite that expression, let's see what that can do for us. And then we'd have, of course, this plus 1. Okay, so secant x over cosecant of x is 1 over cosine of x over 1 over sine of x, multiplying by the numerator by the reciprocal of the denominator. So 1 over cosine x times sine of x over 1. We end up with sine over cosine, which is tangent of x. So it turns out that this secant x over cosecant x can be replaced by tangent of x. And then tangent times tangent is tangent squared of x. Then plus 1. So if we were to look at our function, notice that it is a fraction, and use the quotient rule, work our way through it, do some simplification, we arrive at the derivative of secant x over cosecant x is equal to tangent squared x plus 1. But let's go back and think about the original function. What if I had paused and thought a little more carefully about the structure of our original function g of x? And notice that I had in my numerator 1 over cosine of x and 1 over sine of x. Then multiplied the numerator by the reciprocal of the denominator. getting sine of x over cosine of x, at that point we might have noticed that g of x is really a camouflaged form of tangent of x. And if that's the case, then the derivative of tangent of x is simply secant squared of x. So in this particular case, we could have saved ourselves a lot of work. However, you may be wondering, well, wait a minute. When we did it using the quotient rule, we got g prime of x is equal to tangent squared of x plus 1. That's not secant squared. Well, it is. It is. It comes from the Pythagorean identities. So just as a quick reminder, if we have cosine squared of x plus sine squared of x, which should be an identity that you have in your head that you remember well, and if we take and divide both sides of that equation by cosine squared of x, so cosine squared of x and cosine squared of x, on the right-hand side we would end up with secant squared of x. And if we expand the left-hand side, we would have cosine squared of x over cosine squared of x plus sine squared of x over cosine squared of x. In other words, we would have 1 plus tangent squared of x equals secant squared of x. So both of these derivatives are equally correct. I hope this helps.